All right. Well, let's see if I can figure out the audio thing this week. Um, all right. Well, hopefully you can see me and let's see. Oh, sounds like I can hear myself anyway. All right. Let's get started. Hopefully this goes a little better than last week. We'll see. So we're gonna go ahead and just recap as quickly as we can. And I'm just checking the audio. It's still up. All right. And let me get this. Hope you all had a good week. Happy Friday. Nice and rainy here on the East Coast. Trying to sound like a radio DJ. Apologies. I am not a radio DJ. Figure out audio systems here. Okay. So, welcome back to our weekly live stream where we're attempting to design a network that you could be proud of that will last a lifetime and resist all of the onslaughts that most likely will come your way when you add anything to the internet. And so what we're trying to do here is make you, or at least arm you with the knowledge and ability to become independent from the Gestapo as these centralized technology platforms become more prevalent. And again, part of that is making sure that you have a good network set up either in your business or at your home so that you can take back that independence, start hosting your own stuff, or at the very least, make sure that your network is secure when you're working from home or your family is using the internet. So move this over here. Make sure my audio is still working. Good. All right. A little all right. So from last week, if you recall, we have our internet, our Comcast internet, and they have a router that they give you. And we are putting in between their router and our network an OPNSense firewall, or it can be, again, any firewall that you choose. And the other thing is we are going to, in putting this firewall in place, we're actually going to create a network that's a little more advanced than what you're probably typically used to. And so we talked a little bit about creating these various network segments using vLANs. And we also discussed, okay, on each of these vLANs, what is it that we want to allow to happen? And so we had our guest network and we were talking about, regular web browsing, email, obviously, if you have guests, they might need to access VPNs or do meetings and maybe even make voice calls. So we're going to allow that. But we're actually not going to allow any access to any of these other network segments. We'll only allow these things, I'm sorry, with one exception. We will allow people using our guest network to access services that we're hosting in our hosting network over here. But everything else is going to be out to the internet. And then the only thing we'll allow on our other networks is if we have a website or something that we're hosting over here in this network. Then we talked about in the internal network, kind of taking a little bit of a different approach whereas in the guest network, we're only allowing certain things and blocking everything else. On the internal network, we're going to kind of reverse that with a few exceptions. We're actually going to allow most things out, and we're going to restrict certain ports that are known vulnerabilities, or at least we're going to control those. And those are things like SSH and some other services that we'll talk about later on. But just to get started here, generally speaking, our strategy here on the internal network is to leave that a little more open and then block known things that are typically vulnerable. And then the rest of it, we're going to essentially do what's called traffic inspection, where we'll allow it out, but we're going to watch it closely to make sure that there aren't certain things that are known bad behavior to actually take place. Okay, so they call that traffic inspection versus outright blocking. Okay, and then on our hosting network, here we're actually going to allow stuff into the network from the outside. So, when we're coming from our internal network over to the hosting network, we're going to allow certain services in. And then same with the internet, we're going to allow certain things to come in from the internet because we want to make those services publicly accessible. And then from the outbound perspective, we're going to also restrict that so that in case something in this environment or in this network gets compromised, because we are opening certain things to the internet, always that possibility. We want to make sure that there isn't the possibility for those devices in this network to cause havoc on any of the other networks or on the outbound side. So we're only going to allow certain things out that are necessary, similar to how we're doing it on the guest access. And then over here on our IoT network, that's all our fancy lights and heating and cooling and fun stuff. We're basically going to make this very restrictive. And the only thing that can get out are services that are absolutely required for these devices to function properly. Okay. They're not going to have access to any of the other networks on the outbound side, or as traffic originating from this network will only be allowed to go out to the internet and only the things that are required. However, we do want to allow, for example, on our internal network, we want to allow the ability to go into this network and manage these devices. So we're going to allow inbound access from the internal network. Okay. All right. So that's kind of the overall logical, we would call it the logical design. And we talking just a little bit about some of the functionality that we want to happen. All right. And then we started to get into last week, as I was flailing around with my audio issues, we started to talk about some of the concepts where sort of the details of each of these networks and the things that we need in order for these networks to function. And so I'm going to spend a little time today going through the details. And oh, hey, Jason's Lab, good morning. Good to see you. Thanks for joining. Sorry, I'm not very good at paying attention to many things. I'm a typical guy. I can't multitask. I'll do my best. Now, here's sort of the anatomy of a network, and these are things that we're going to need for each network. So we talked about the vLAN, okay? So for our guest network, we're using vLAN 10. And again, think of the vLAN as a sort of a virtual switch, if you will, or a switch that, or a sort of a network segment. It's a boundary that allows us to isolate the network and control the traffic and control what's in it. And then, so we're on vLAN 10 for our guest network. We need what's called a DHCP service, so that, and that stands for Dynamic Host Control Protocol. And essentially what that does is when a device connects to a network, it needs an IP address in order to communicate on the network. And what DHCP does is it hands those out. So it keeps a database of all the existing IP addresses that it's already handed out, and then picks an available one and assigns it to that specific device. There's a lot of detail around how that process happens, but just know that, if we don't want to have to manually configure an IP address on a device every time we add it, we need this DHCP service to help facilitate the actual connection to the network. Now, the next thing we need is a DNS server or a set of DNS. And DNS stands for Domain Naming Service, and or server, depending on the context. And the DNS, or the Domain Name Service, what that does is that translates, think of it kind of like the post office, it translates these IP addresses to names that we can remember. So when you go to google.com, for example, what's happening there is your computer says, hey, I want to go to google.com. And it needs to know, okay, now what address do I need to go to in order to get to google.com? So think of it like this. I want to go to Nate's house, right? So you know Nate, and you know that he has a house. I guess you do now. And in order to get to Nate's house, you need to know the address, which I'm not going to tell you. Probably find it on the internet. But in order to do that, you go look up the address somewhere. You go ask maps.google.com, or you go to the post office and you say, hey, where does Nate live? Give me the address. And so that's what DNS does, is it says, okay, you want to go to Google, here is the address. And so we have to have these servers that do that process. And so we're going to tell our guest network to, when you need to know how to get somewhere, go to this address and this address is 9.9.9.9, and this other number 208.67. Okay, so that's what DNS is. Now, on our guest network, we're also going to have Wi-Fi access. Okay, now Wi-Fi access, you're probably used to just what's the Wi-Fi password, right? That's what's called a pre-shared key. And you can, and in the case of our guest network, we don't actually want to have a pre-shared key in our scenario because, one, if you give out the guest access, it can, over time, people learn it, they share that, and you might not necessarily want just random people joining your guest network, okay? And so we're going to use what are called guest passes, and we'll talk more about that later on, but basically, think of that as like a one-time password that will expire. So you hand those out and the person uses it and maybe it lasts for 3 days and then it no longer works. And so they need another guest pass in order to connect to the Wi-Fi network. It's just a more secure approach to managing guest access. A little bit of management overhead, but it's minimal, and in the long run, it's a much more secure approach to Wi-Fi, giving guests Wi-Fi access. Okay, and then maybe in your house or your business, you designate certain ports on the wall, like a network jack, where if you plug into that, it goes to the guest network, and that's the only thing that jack can access. So we will do that. We'll allow that on certain switch ports. Okay. Now, the other thing we need on our guest network is we need a way to override a DNS answer. So if I go and I say, hey, I want to go to nateserver.nate.com, and I know that server is hosted over here in this other network segment, I need a way to tell the DNS process to override what this public server is going to answer with. Okay? Because if I ask this public server, this 9.9.9.9, hey, how do I get to Nate's server? It's going to give the public answer, meaning whatever the internet IP address is. I haven't talked about that yet, but on the outside of the network, there's also one of these IP addresses that the internet provider is giving to my network, or at least if we come back to our logical design, at this level, okay, right here on this side, we have a public IP address, or it could be up here on this side at this connection point. But we're gonna set our Comcast router up as into what's called bridge mode. So it's just going to pass the traffic down to our firewall, and it'll be our firewall that will have that public IP address. So anyway, when we register those details with the internet and we ask a public DNS server, it's going to give us that public IP. Now, the challenge here on a guest network is, okay, well, if I'm already kind of inside the network and I have to go out to the network and then come back in over here, we can do it. There are some tricks, but the simplistic way to do it is to actually intercept this request here at the DNS level, and then say, oh, you want to go to this service, go to this other internal IP address. Let's say 192.168.30.22 or something. And then in the firewall, we say, okay, if devices in this network segment are coming to this 30.22 address from this network on this, seeking this service, so let's say web or secure web, HTTPS, then allow it. Otherwise, block everything else. So the way we do this DNS override is here in the DNS server list. We're going to actually add an internal IP address of 192.168.10.1. Okay, and I totally forgot another piece of information that we need on these. And now let's add that here. We need what's called the gateway. Okay, and the gateway is the first hop, the first IP address. Oh, resize all this information. Okay, give me 1 second. Good job, mate. Made a plan. Bear with me. The joys of open source. All right, well, I'm really jacking this up. Give me 1 second. Let me see if we can do it. What is happening? Can't do them all at once. Bug 16. Oof. Oh my gosh. Nightmare. So the gateway, if I can talk and do this at the same time, is how we get out of the network. So when we're going to somewhere inside this network, inside this 192.168.10 network, we don't need a gateway because everything is we can connect directly to a device or a server. But if we get if we need to go outside the network, so let's say to this other okay. Well, we'll let the other ones go. Let me just move. To get outside the network, we need a gateway, which is basically tells us, okay, if it's not inside the network, go to the gateway, and then the router will send the data from there out to the network that it needs to go to. All right, so that's what a gateway is. Wow. And so at this DNS level, we're going to use our gateway as an actual, in a way, a DNS server, and we'll be able to override what the public side would answer if we needed to go to a service that was over here. Hopefully that wasn't too confusing, but so we're gonna do that kind of on each network. And so in order to do that, we're going to use OPNSense to provide these DNS overrides so that if you get a question that can be answered internally, it will do that. Otherwise, it will forward everything else to these other DNS servers. All right. Okay, so that's the, let's see, that's the setup of our guest network. We'll talk about the DHCP range. You know, you can, depending on the network, you can change this. I mean, the way that I think about DHCP ranges is how many devices do I want to allow on my network? So if I have a party at my home, for example, and I have more than 90 people coming, then I would want to make this range bigger if I wanted all of them to be able to get onto the guest network. Now, my house isn't that big, so I don't need that many IP addresses, and 90 is plenty. Could even make it smaller if I wanted to. We also talked about kind of reserving certain sections of the range for things like static IP address or devices that you want to have static IPs. In other words, we don't want the DHCP server handing out a number in that particular range because we're going to use it for some other purpose. Okay. Let's see. Audio still good? Check. Certain section. Yeah. Okay, we're good. All right. Now let's talk about our internal network. So our internal network, we're using vLAN 20. Our DHCP range is a little bigger. So we're starting at 11 and going to 200 instead of 100. And here we have our DNS server override, or our DNS server, internal DNS server, which again is going to be the gateway. Maybe we'll just do it that way. This on our network here, this is the gateway address. And we're going to use it for DNS responses so that if it asks for something inside, it will give the inside answer instead of the outside or the public answer. And with Wi-Fi, we're not going to do guest passes because we don't want to have to, you know, we have a device that we're always connecting to the internal network. We're going to do a pre-shared key, like a Wi-Fi password. But in addition to that, we're actually going to only allow certain physical devices on the network. So you have to register, like if I get a phone, you need to tell me the MAC address, and I will plug that in to only allow that MAC address on this Wi-Fi. So it adds another layer of security that helps protect from just random devices connecting to your internal network. Now, this isn't foolproof. In other words, MAC addresses can be spoofed if somebody knows which MAC address they need to spoof, they can technically do that. Now, if that MAC address is already on the network, you will notice problems on the network with devices connecting because you can't have the same MAC address on the same network, because then the devices won't know which device with the same MAC address to send the data to. So you'll start seeing all sorts of weird stuff, which would be an indication that there's potentially a security breach. All right. Now, and then wired. So if you have certain network jacks at desks or in your somewhere on the network, then you can allow wired access on that VLAN. Okay. Same with the DNS. Now, hosting is going to be a little different. We're not going to allow Wi-Fi. We're going to have what's called a trunk or an access port. We'll talk about that in a second. And we're not going to hand out any public DNS servers. We're going to just use our local DNS server on our firewall or our gateway for our hosted network. All right. And then in addition, we're going to do something on this network, not technically on the network, but we're going to use what's called dynamic DNS, because our Comcast people up here, they're using, oh, not here, here. Comcast is on their network or their internet, they're using DHCP. So when they send a router out to a home, they're just basically doing the same thing we're doing on our internal network using DHCP. And they're handing out a dynamic address, and that's going to change every so often. And so in order to host something inside this network on the internet, we need to make sure that the internet knows the current IP address. Like if this changes, Comcast changes our IP address that they're giving us, we need to make sure that the internet knows that, hey, this is the new IP address. And there's a service that we can set up called dynamic DNS with our DNS provider, where when this changes, when our public IP changes, then this service will say, hey, here's my new IP address. Make sure the world knows about it. Okay, so we're going to implement dynamic. And then one other thing is we do need a DHCP range so that when we connect a server, we can get it talking on the network. But then we're always going to, in the hosting network, always going to assign static IPs. So we're just using this DHCP range to get started so that we can connect to the server and then configure it manually once we've connected to it. And so that's why we want a DHCP range on our hosting VLAN. Same thing. We're doing on time. I think today we're doing pretty good. 10:27. Almost there. Okay, so finally our IoT network. We're going to make the range a little different. So we're going to give 150 IP addresses. We're only going to hand out our public DNS server, so we don't want any overrides because we're not going to allow anything on this network to go anywhere else besides the internet on the outside. So we don't want any overrides. We don't want it knowing about our hosted services. We don't want it accessing anything on any of the other networks. We're going to do something similar on the Wi-Fi because some of the devices will probably need to connect Wi-Fi via Wi-Fi, but we're also going to just restrict what can connect using the same methodology with a pre-shared key and a MAC address. And then if a device needs to plug into the network and it doesn't have Wi-Fi, we're going to use access ports, or we're basically going to restrict whatever it plugs into to only the VLAN 40 that we're using. And then again, no public DNS overrides for private public. All right. Okay, hopefully that was useful, helpful, but I think we're almost ready to kind of get started building this out. There are probably a few more concepts we'll want to go over next week, just to make sure that we're using, everybody understands sort of like conceptually what we're talking about, like things like access versus trunk. We'll go over VLANs again. We'll talk a little bit about MAC addresses and maybe go into some other concepts around how networks, like, for example, internet. Okay, the internet is just a bunch of networks. That's all it is. There's nothing special about it. It's just another network that's outside of your network. And so you may have heard concepts like WAN versus LAN. And so we'll just go over what kind of distinguishing what some of that stuff means. And 10:29, wow, no audio issues this week. Got through my spiel here. Hopefully it was a little coherent. And next week, we'll just kind of recap on some of the terminology, and we'll actually start building out some of this infrastructure. It'll be fun. Hopefully you can join us. If you did join us today, thank you very much. We appreciate your time and your attention, and hopefully it wasn't wasted. And have a blessed and wonderful weekend, and we'll see you next week. Take care.